Alright, this is an introductory video on how to classify reactions. Now, in truth, there are two main classes of reactions. One of them is called a redox reaction, which stands for oxidation reduction reaction. Okay, and what that pretty much means is there's some way, shape, or form a electron transfer taking place. Okay, these six equations, or these six different types of reactions that I have listed right here, um, are classified as either being a redox reaction or not redox reactions. Okay, um, we will in future lectures talk about how I can determine if it's a redox reaction or not. Other than, well, if I know it's a synthesis reaction, I also know it's a redox reaction. Okay, I'll show you. We'll dive in a little more into the actual transfer of electrons and what that looks like. But for this particular video, we're not focusing on that. What we are focusing on is these are the six types of reactions that I'm expecting you to be able to identify, and I'll give you key, some keys as to how to determine that. Okay, the first is one that hopefully you're familiar with, and that is a precipitation reaction. Okay, a precipitation reaction is not a redox reaction. That's why I have it in green. Okay, so not a redox reaction. It's also known as a double displacement reaction, where you'll end up having, the cation of one and the cation of one reactant and the anion of another reactant end up meeting up, and then the anion of the first reactant and the cation of the other reactant match up. Okay, and then of course if a solid is formed, then you end up having a double displacement reaction. Okay, if they don't match up, right, because if both the products are still soluble, then you don't really have a reaction, you just have a mixture of ions. But a good way to think of this precipitation reaction is when a solid is going to form based on aqueous reactants. Okay, so aqueous reactants resulting in a solid product, okay, or at least one solid product, is going to be a precipitation reaction. Okay, there are times when you'll have two solid products, but for the most part, we'll only have one. Okay, the next type of reaction, which is also not a redox reaction, as indicated by the green, are acid-bases reaction or acid-base reactions. Okay, and those are also called neutralization reactions. And the reason why they're called neutralization reactions is because the acid and the base neutral each other out, right? We have acids that have a very low pH, and we have bases that have a very high pH, and I'd say very, I'm just, comparative, right? In compared to 7, right? 7 being neutral water, pure water. The whole idea of the acid and base coming together, and it's going to make a neutral product. And what I mean by a neutral product, meaning neither of the products being acidic, or another word for basic is alkaline. Okay? The products for acid-base reactions are always the same. Okay? There's always going to be two constants. One of them is going to be liquid water, and the other one is going to be some sort of ionic compound. That ionic compound may be soluble, it may not be soluble, but you're always going to have liquid water as a product, and you're always going to have an ionic compound, right? A metal and non-metal combination. Okay? There are cases in which you might end up with a gas, but we're not going to focus on those. Okay? Now, the last four reactions are redox reactions, meaning electron transfers are in place, and they're pretty straightforward, right? We have a synthesis reaction. Now, synthesis reaction, if I was to draw an example, it would be something as simple as having more than one reactant, but only one product. And that's the easiest way to look at it. So if I have A with B, it'll react to form AB. Okay. Likewise, a decomposition reaction would be if I had one reactant and then it broke down into two or more products. Okay. So I could have CD breaking down into C and D. Now, I'm not limited to just two, I'm just saying as a minimum, right? For synthesis, it could have been A, B, and C coming together to make ABC. And likewise, with decomposition, it could have been C, D, E breaking down into C plus D plus E. Okay, but I just did two just to make it simple. Okay? A single replacement is it's a little different. And what I try to encourage when trying to identify a single replacement is look at the metals. Okay, and what happens is metals are involved here, and the metals are going to switch partners, right? They're going to switch partners. Okay, I can give you an example of that right here. Okay, let's say I had, come on, there we go. If I had zinc 2 chloride and silver metal, okay, what's going to happen is this metal right here and this metal right here are going to switch places, and I'm going to end up with silver chloride and zinc metal. Okay, I'm not worried about balancing it right now. I'm just wanting to show you that if you notice that this metal and this metal just switch places. Okay, that would be the example of a single replacement reaction. Okay. Now, the last one is a combustion reaction. Okay, and combustion reactions are also pretty easy to identify because there's going to be one reactant that's always there, and there's going to be two products that are always there. Okay, the reactant that's always going to be there. Okay, the reactant that's always going to be there is going to be oxygen. Okay, diatomic oxygen will always be a reactant here. Okay, I could have, in many cases, usually combustion is referring to a hydrocarbon, like a substance that composed of hydrogen and carbon. Okay, but just to keep an idea, combustion is burning, and burning is usually in the presence of oxygen. So I want you to associate combustion with oxygen as a reactant. Okay, and then my products, I have two. One of them is water, and the other is carbon dioxide gas. Okay, so I mean technically we have two products here, one reactant that's going to signify a combustion reaction. Okay, an example, right? If I was to do one real quick, let's say I had methane reacting with O2 to form CO2 plus H2O. Okay, the presence of this on the reactant side and these two guys on the product side should automatically indicate combustion reaction for you. Okay, so that's the kind of thing that you're looking for. All right, but that's pretty much a quick summation of how to identify different types of reactions. Okay, precipitation, same thing as double displacement, like the formation of that solid, right? From previous looking at solubility rules. Okay, acid-base reaction or neutralization reactions. Okay, where you have an acid and a base coming together to make water and an ionic compound or a salt, right? Water and salt are always my products. Those are both not redox reactions. And then synthesis, decomposition, single replacement, and combustion are redox reactions, and how they are classified. Synthesis is when I have more than one reactant, but I have only one product. Okay, decomposition is when I have one reactant, but I end up with more than one product. Single replacement is when I have the metals of the equation are just switching partners. So one metal will become the metal that was part of the compound will now be a metal on its own, and the metal that was on its own becomes a part of a compound. Okay, so like I said, they just switch partners. And then the combustion reaction, I'm always going to have oxygen as my reactant, and I'm always going to have water and carbon dioxide as my product. Okay? If you get some questions, by all means, let me know.